Yeah, this talk is about breaking backwards compatibility, which is something people are not supposed to do. So I'll try to make it the easy way, so that you can just make all your users suffer, because every time you will release a software or a new version of your software, everyone will feel pain because you broke backwards compatibility. Before I get there, some disclaimers. I normally speak very fast. It is not because I'm nervous, but because I'm from South America and we don't lose time there. And the other things, I normally say bad words. Don't take it on me. And it's not against you. It's just like when I get really into topics, I just start fighting bad words. And yes, I guess those are my disclaimers. And I probably have more disclaimers than slides. Like many people have issues with fitting 80 slides in 20 minutes, and I have issues with like extending my 10 slides in 30 minutes. That's me. That's my Twitter handler. That's my email address. If you think this talk is good, let me know. If you think it sucks, let me know as well. I'm happy to discuss things. Thanks for attending, and questions, feel free to interrupt me at any time. I don't mind. Just raise your hand and we can do questions and answer at runtime. And I'm still working at Red Hat. I work in the Openstack team. We'll hear a little bit more about Openstack this afternoon. And yeah, I still work for Red Hat. I don't work for STX Next, although I feel very close to you guys for various reasons. So before we get started, who knows what compatibility is? Who knows what backwards compatibility is? Show hands. Up. Okay, good. Do you guys know that there's also forward compatibility? Hands? None. Okay, just like 2. Okay, that exists. So this is what you'll find in Wikipedia about backwards compatibility. So software is backwards compatible if the new version of your software or your product or service works with the older version of your product or service or whatever. That means that every time you upgrade, the old versions will still work. The old software that were consuming your service or your libraries or whatever you're working on will still work. Just to give you an example, kind of analogy, like a roller coaster is backwards incompatible, because if older people get into a roller coaster, they might have a heart attack and they will die. And if very, very young people get into a roller coaster, I mean, they can because there are some rules, so it is also not forward compatible. And that's kind of like the whole rule of the thing. And to break backwards compatibility, the easiest way probably is to don't use versioning. If you have a piece of software and you don't have versions at all, it will be very easy for your users to, suffer pain every time you have something new to add to it, because you release your software, you don't have a good versioning, they don't have a good way to control it. Another way is to don't deprecate things, just delete them from your source code, and every time you will release your software, your users that were consuming some functions, they won't find them there and they will suffer as well. And keep everything inconsistent. That is good. If you want to make your users suffer, you can just keep all your functions, all your signatures inconsistent. And like every time they will have to learn your application, every time they will have to use your service, they will have to just learn it from scratch. And you can also assume that you are the user. And if you assume you're the user, you'll do things your way, and you will just ignore your users' requirements, and you will know everything that your users need. Unless you are the only user, like the real only user, and then you will suffer yourself. That's masochism. And keep everything public. If you keep everything public, you'll just like all your users will use whatever you're exposing, and you don't have the trouble of just deciding what has to be public and what hasn't. Keep your users in the dark. That means don't tell your users what you're doing. That way, every time something changes in your applications, they will definitely suffer because they don't know what you're doing nor why you're doing it. And well, that's a good way to just like hide the things, hide your evil plans, and make people suffer. However, in a most serious note, I really wanted to just give the talk and make like random jokes and really focus on how making people suffer. But then I realized that some guys might take me seriously here, and I don't want people to take me seriously there. Like every time I said, just forget it, you don't want your users to suffer, you want to actually keep backwards compatibility. And we're not going to go through some of the ways, or let's say things that you have to take care of in order to guarantee backwards compatibility. Some of them are things that go just against of everything I just said there, and you should probably just follow that. And let's be honest, you've been the hacker. At least once in your life, you've been that person that has broken backwards compatibility, either accidentally or on purpose, but it's very normal. Like we do it very often in Openstack. Like I said, I work on Openstack, and it's an open source project. Who knows what Openstack is? Good, good. So, well, OpenStack, we'll talk a little bit more about OpenStack in my second talk today, but OpenStack is an infrastructure as a service, or how I prefer to call it is cloud. It's cloud as a service, basically. It's a cloud provider. Well, at least the software that is supposed to provide that. And we have a lot of services, and we do this very often. Like we accidentally break backwards compatibility, and we need to be ready to just fix all the issues we have so that our real users, the people consuming the provider, the people consuming our code, won't suffer the pain we're suffering in our testing units, and we'll see that in a little bit. Before we get there, why does it matter? Like, why backwards compatibility matters? Like, one would say you shouldn't waste time explaining why it matters. Like, everyone should know why it matters, but not everyone does that. I know everyone knows why it is important. And the first thing is that it helps saving time. Like when you have something that is backwards compatible, you don't have to worry about you breaking other users and then going back there and fixing all the issues that you just caused because you broke backwards compatibility. And since time means money, basically, you're also saving money. And it's not about the money you save because you're saving time. You're also saving money because in the case where you have like real customers, like in our case in OpenStack, our users are people just using OpenStack. And so Rackspace uses OpenStack. I'm pretty sure most of you know Rackspace. And so in our case, our problem as a community, as an open source community, is not the fact that we're going to break OpenStack, we're going to break Rackspace, because they are not our customers. But in the case where you really have a customer that is actually paying for your software and it's consuming all your services, every time you break their code, they'll get mad and they'll probably just go away. So you really need to take care of your customers and provide them like the best way to move forward, the best way to go from 0 to 1 and then 2 without having to jump from 0 to 3. And if they really have to jump from 0 to 3, you have to have everything well documented. And if you're backwards compatible as much as possible, that should be less painful. And well, it does save kittens. It saves kittens because every time someone like breaks backwards compatibility, it makes someone else really mad. And because you have your software, you dedicate time to it. When I'm consuming someone else's library, I dedicate some time. Does it work? Hello? Okay. I dedicate some time like learning the library. I read documentation. I try to find the best way to use it. I contact authors because I want to know what was in their minds when they were doing something, like when they were developing that library. So I'll always try to find the best way to use it. And when the author is like basically playing against me, that's wasting my time, and I will get really, really mad. And this is another disclaimer I didn't say, like I rant a lot, and if you follow me on Twitter, you probably know that. Like I normally rant about things that I don't think are right. I'm mostly wrong, but anyway. But yeah, like you have to take really care of the people using your software because they are the ones that are actually keeping your software alive. If you're the only user, you might have fun with your software, but at some point you will get sick of it and you will probably stop doing it because it is not worth it unless you're getting money out of it. So yeah, I mean along that line, one of the most important things, and I really believe this, it's not versioning, it is not consistency, it is not testing, but it's communicating with your users. everything you're doing in your software has to be crystal clear. Like, people need to understand what you're doing and why you're doing it, because the way you communicate the changes you're doing in your software, I mean, the better you communicate those changes, the easier it will be for your users to just upgrade and use the new versions of your software. Remember that users can be either real customers, like even a PlayStation has backwards compatibility. When they release a new PlayStation, and you can play your old PlayStation's games in the new one, that's backwards compatible. And that's a decision. Like, they literally decide to just do that, because if they don't, you will basically have to buy all your games from scratch, like for the new version. So some consoles, like they would say, if you want backwards compatibility, you just have to pay for it. But others, like most of them, just let you play your old games. So communicate with the users. Let them know what's going away. If you're going to remove something, make it real clear. Like, warn the user, print warnings everywhere. Don't print them every time. Like, make sure you don't fill all the logs with warnings. Like, hey, I'm going to delete this function every time you call that function, and turns out that's the login function. So warn the user, make messages very clear. Don't be afraid about logging like long messages if you really need to. Like, many people try to, like, it's very common to just use a single line login where you say, hey, we're going to remove this function in version 0.3, and without explaining why, without explaining what's the new function that they should be using, or if there's going to be a new function. So be very explicit, communicate properly with your users. Do at least, like, take at least one cycle to deprecate things. And by one cycle, it means that the old function will be in your code base for at least 2 cycles. For example, if I want to deprecate a function and we are on the version 0.1, I will write a log there and I'll tell you, hey, we're going to remove this function in the version 0.2, and then I release 0.1, and I then can delete it in the 0.2. So I'm giving you a full cycle of my release cycle to move away from that function that you're using to the new one, right? So you definitely want to do that. You want to communicate clearly with your users. You want your users to have enough time to move away from whatever they're using to the new one. And if there's not going to be a new one, at least propose something, like give ideas to your users so that they can properly update their software without crying and breaking it. And have very clear release cycles. It doesn't have to be a 6-month cycle. It doesn't have to be a 1-week cycle, but there has to be a cycle. You have to define whatever works best for you, use it, and stick to it, because that's what your users are going to rely on to estimate the time that you need to upgrade their software towards the new version of your software. So it is really important, and some users will decide not to upgrade their software for every version, but probably every 2 versions or every 3 versions. And that's something that, depending on how many users you have, like I'm mostly talking about open source software because that's what I work on right now. But depending on your software and how you interact with your users, you might want to find like some place in the middle that fits both of you. And then we go back to versioning. Versioning is hard. Like, there are many ways to version software. I don't think there's the right one. But please, like I said, there are many ways to version software, so don't reinvent it. Like, try to use whatever exists out there as a, like, I'm not going to even say correct format, but as a standard format to do software versioning. And try your versions, like try to use your version as a cross-platform version. Like, some people use versions that are very specific to Linux environments, and if you have users everywhere, they might not know how the versioning works. And the same thing applies for languages. Like, not all languages use the same versioning style. Some languages use, I don't know, major and minor. Some other languages use semver, and some other languages might just use a major version release kind. And just try not to stick to the version system that your language is using unless you're like developing a library and you expect your users to be on that environment to know very well how that versioning works. And in that case, okay, I will advise you to just stick to that because it's easier to adopt users. But if you have users from everywhere, like if you're developing a service and you have an API and you want users from everywhere, every platform to use your API, you might want to have a way to version your software in a way that people will just understand it without having to learn the language or the way the language of your preference works or the platform of your preference works. And one of the latest, I guess, but it's not that new, ways to version software is using Zemver. It's very simple. It stands for semantic versioning, and it just uses three-dot versioning. You have a major version, then you have a minor version, and you also have a patch version. So every time you apply a patch to it, to your software, and you release it, you can just increase the patch version. That means if you find a really, really tiny bug, or you have to fix something really quickly for your customer, you just can like patch it and release it and give it to your user and say like, okay, this has the patch version, I don't know, 100. But if you do changes that do not break backwards compatibility, you can easily just upgrade the minor version because you're adding things. You're not changing the way your software works. And breaking backwards compatibility doesn't mean deleting code. It also means changing the way your software works. If your function, for example, used to return an integer and it now returns a string, you are breaking backwards compatibility because you're changing the way your function works. So every time you do a change that does not break backwards compatibility, you feel free to just upgrade the minor version and release a new version of your software. But instead, you also, if you break backwards compatibility, because you have to, sometimes you have to, you don't want to live with your legacy code forever and keep releasing new minor versions without deleting the old code that no one is using or that you assume no one is using. So every time you have to do a release that breaks backwards compatibility, you feel free to upgrade the major version. And in that way, you're telling the user, hey, big changes are coming. I recommend you to just read the change log, read all the warnings that we have been printing. We have like posted blog posts for a month already explaining what we're going to do. So I expect you to have read those and to have prepared yourself for the next major version. And they will decide when to upgrade. They will see the major version and they will read what the changelog says, and then they will decide when it's the right time for them to upgrade. But it's like I said, you have to communicate with your users, and this versioning is a way to do that. It is clear, it is explained, and it says when something is backwards incompatible. So adding many new features does not mean breaking backwards compatibility, so it does not require upgrading the major version. Just backwards incompatible changes do. You have to have a consistent API. It helps users migrating from an older version to a new one. And by that I mean, I just don't mean, like API can be anything that your users rely on to communicate with your service. It can be an HTTP API, it can be a function if you're working on a library. Even the remote controls of your PlayStation have an API that you're used to. So make their API consistent so that when you add a new function and you want your users to migrate from that old function to the new one, and I keep speaking about functions because it's easier to reason about libraries from a developer standpoint. And if you write a new function and you want your users to migrate from that older function to the new one, and you have a consistent API, it will be very intuitive for them to migrate from the older one to the new one. They will just know how your library works because they know you already. They have been using it for a bit. So if you, for example, have your arguments are named as a user and then project, please, in the new function, does not change your arguments to username and then project ID. Just keep using the same arguments, make your API consistent because it makes it easier for them to migrate from the older version to the new one. And it also helps you to maintain your software because you know how your software works. You just follow a standard. You don't have to wonder every time how I'm going to name this variable, how am I going to name this argument, or how am I going to name this function. You just follow your standard. You keep everything consistent, your users are happy, your life is simpler, and no kittens will die. And then design buying contract. And by that I mean So who knows what design by contract is? Like 3 hands. Okay. So design by contract. This was written, created, or designed, so to speak, by the creator of a language called AFOL, and where he said that people should have contracts every time they develop software. And what that means is that, like, the analogy is the same as a customer and a vendor. Like, every time you have a customer, you have a contract with them. And you say, I will provide you this, and this, and I expect you to give me that, and that thing. Like, there's a contract, you sign it, and you know what you're giving them. And if you don't give those things to your customer will get mad. And if the customer does not respect the contract, you will be mad. And the same thing applies to programming. Mostly on programming languages like Python, which don't have any kind of, well, I was about to say something really bad. It does have a type system, but it has a dynamic type system, which does not provide any guarantee from a type perspective. And that basically means that every time I call your function, I could be passing anything. So you need to have a contract. You need to have a contract with your users. You need to have a contract within your application. So if you expect something to be passed to your function, make sure those things are passed. Don't just ignore wrong input. If you're expecting an integer and someone passes a string, don't just keep it and move on, because then your users won't know what's happening there, and you will just like break the contract because the user is breaking the contract. You're just ignoring it. And that way just creates a mess in your application, and it's really hard to maintain. So for programming languages that does not provide a way to guarantee type, which do not provide a type system that makes it easier for you to guarantee that contract or to respect that contract, you have to implement the contract yourself. So I really recommend this. We've had like several issues in Openstack where functions did not make users respect this contract, and they would just keep things or check for the type, and if the type was not the one expected, they would just move on and pretend nothing happened. And that created, like, that made many people waste hours of debugging. So have a contract. Privacy rules. I wish we could just have all languages being private by default, like Roslang. And the reason is, it is very easy to forget that things that you're developing are public and that your users can access them. And in this case, like, this slide is very, very development oriented. Like, well, yeah, even if you have a service, make sure your endpoints, like the endpoints you expose to your users are the ones you really want to expose. But from a development perspective, and specifically speaking about a language like Python, which like Python's privacy rules are like Python privacy rules are like Hollywood's rules. Like, basically you think everything is private, but everyone knows what you're doing, and everyone can access your functions, and you don't want that. Like, yes, you can use the underscore on the front of your, like, prefix your functions with an underscore, and you pretend people won't use those things. But turns out there's many people that uses your private functions anyway. So don't assume people respect those, although if you have a contract and you said, hey, this function is private by prefixing it with the underscore, and you want to remove it, just feel free, because that's the standard way in Python to mark something as private. And if someone is using your private functions, they are just doing it wrong, and you should feel free to break their software because they shouldn't be doing that, basically. And don't expose internals, common utils. If you have your convert from string to an integer function, the user really doesn't care about that. Just hide it. Make sure that's not exposed in your public API, because users will use it, and you don't have a way to prove that. Like, that's probably one of the hardest things we have in OpenStack right now when it comes to libraries, and is the fact that we don't know who is actually using our public functions. And we went from a point where, like, I don't want to say we didn't care about backwards compatibility, but it definitely wasn't our priority, like our biggest priority there. And we went from incubating libraries to kind of graduating many of them into proper libraries that users could consume and feel safe of doing so. And we found out that there were like so many public functions in those incubator libraries that we couldn't just remove. And we couldn't just say, hey, like this function is going away, you should move to that one, without providing a deprecation path. And the reason is that you really don't know who's using those functions. There's no way, like you would say, yeah, who's going to use my function that converts from string to integers if you have like a whole bunch of built-ins in Python to do that? Well, it turns out that there were people actually using them, and we broke their software, and then we learned that you cannot assume that kind of things with Python unless, if you have a language that does provide a good way to make some things private, then you can just assume it if the language works properly. But in Python, you can't. So take good care of what you expose in your libraries and your software, because once you make something public and you release it, you're doomed. Like, you have to maintain it. You have to take care of that function. You have to take care of your users. And if you want to upgrade it, you have to go through all the deprecation path. You have to warn the user that you're going to delete it and all that kind of things. Like, it's not like I just released it in the last version, so I assume no one is using it and I can delete it. Remember, there's people that actually read the code, there's people that actually read the documentation, and there's people that is actually interested in using your library the best way. So if you put it there, you will have to maintain it. So be very, very careful on what you make public in your application, in your library. And make sure you have your stability rules clear. And by that I mean, there's no good way to just say, my software is stable, because let's face it, in our industry, you can say that something is stable and it will break the next day. But you can say that something is, that some functions API, some software's API or services API is stable in terms that it won't change in the future. It won't face major changes in the future. That means that all the changes you will do are probably minor, and if there's a major change, it's just because something is horribly broken and you definitely need to upgrade it. So, like I said, at the very beginning, warning the user, communicating with the user is it's probably the most important thing to do to guarantee backwards compatibility. And you have to communicate the stability rules of your software. You have to be very clear when something is unstable, because when something is unstable, you should feel free to just upgrade it. If you tell your user, hey, this function here, we're releasing it, but be careful because we don't consider that function stable. It is, I don't know, in a testing phase. That could be also a new feature. It doesn't have to be a function in your library. It can be a feature in your service, in your API. So communicate properly all your stability rules and make sure your user has a way to introspect those, to just go through your software and know what's considered stable and what's considered unstable. Because remember, like, when something is unstable, you should feel free to just upgrade it and break backwards compatibility, because you warned the user and you told them, hey, this is not stable enough, so if you're using it, it is on your own risk, and I'm reserving the freedom to just break everything on that function, because like I said, I don't consider it to be stable. And testing. This is, how am I doing about time? I'm really done already, which is good because we're hungry. And testing. Oops, that wasn't, like, I'm hungry, but not that hungry. So unit functional test. Okay, we all take that for granted. It was very fun when someone asked, like, are you testing your software? I was like, oh, Jesus. But like, we take that for granted, right? We assume people is testing software at least with unit tests. Like, that's the minimum necessary. But then if you add functional test, it is good because you're trying to test against things that are actually running, that you're testing your service, you're testing interactions with your database, you're testing interactions with other services, and with your users. But that's not enough. If you really want to guarantee backwards compatibility, you have to have integrated testing. What does it mean? Like, integrated testing means that you will have example applications, or hopefully your own users' applications, testing your new releases. Every change you do to your software software will run through a gate, through some checks, some Jenkins jobs that will test it with your user software. We do that a lot in OpenStack just because of that. Because we have breaking backwards compatibility so many times that we are so afraid of merging anything without having an integrated test. So what does integrated test mean in OpenStack? So think about a library that is being consumed by many projects. So every time we propose a change to that library, that change is going to be tested for every single project we have in OpenStack, because we don't know who's using the library, right? So we have a set of projects we consider core and we don't really don't want to break, and those tests will run through those projects. If you change an API in one of those projects, so say you have your compute service, which is called Nova in OpenStack, and you have your image provider service, which is called Glance. If we do a change in Glance, which is a dependency of Nova, we'll run a test suite that will test Glance running live with Nova running live, and we have a whole bunch of procedures like spawn up a new virtual machine, delete the virtual machine, create a snapshot of that virtual machine and upload it to Glance and all that kind of things. So that's integrated testing. You're making sure the basic functionality that one software, the software A, relies on are not broken for because of the change you're doing, basically. So unit tests, good. Functional testing, good. But please do also integrated testing. That's an extra guarantee for you. Remember, guaranteeing backwards compatibility basically saves you time and money. So that's an extra guarantee for you that you're not going to make someone else suffer a lot because some change that you wanted to do eventually. And if it is possible, run those tests cross-version. If you, in our case, like in OpenStack, we have 3 different kind of like releases. Like we have our master branch, which receives all the changes. Then we have the master -1, which is the current stable, and then we have the master -2, which is the older stable we're going to deprecate in the next release. And so the -1 version receives all the bug fixes, and the -2 versions just receives the security fixes. So if there's a security hole, we'll backport the patch from master to the -1 to the -2, basically. And the rest of the bugs are fixing just in the master and the -1. And the reason I'm saying this is because if you can, in our case it's really difficult, but if you can, you should be testing also interactions between your -1 version and your master version. It is not about the services running all in the same version, but if you want to guarantee rolling upgrades, which means you will upgrade your infrastructure one piece at a time. You're not going to upgrade all the software at the same time because they have to work all with the same version, but you want to upgrade it one step at a time. And if you want to that, if you want to be able to that, you need to make sure that the version you're going to release of that new software works with the older version, like I said, backwards compatible, and you need to have a gate for that. You need to have a Jenkins job for that or a CI job for that will guarantee that. So it installs everything, it runs all tests live, and it will allow you to have that extra guarantee and sleep well at night, basically. And like I said, that's pretty much it. And I think I have like 10 minutes for questions. Actually 5.
Hello.
This one? I can yell.
Okay, any questions?
Seriously? I know you guys are hungry, but
Yeah.
come on.
For sure, I have a question.
Go ahead.
So what's the best level to document backwards compatibility? Is that like a end user documentation level? Should it be like a Java doc style? Should it be a language feature? Like how do you, a log message as you mentioned?
So I'll tell you how we do it, but I'm not saying it's the best way. So every time we change something on OpenStack that is supposed to be documented, it has some API impact. We call that API impact. We're basically changing the API. We tag our commits with that. We put a tag on our commit message that says API impact, and then we have a documentation team that just goes through that and also upgrades the documentation based on the changes that happened in that change base. And the commit message obviously has all the explanation of what's changing in that commit, so that, the documentation team knows what's happening there. And it's not only useful for the documentation team, but we also have many people consuming OpenStack know how to use Git. know how to read commits. So every time like they want to know if there are some API changes, they can just git log it and just grab on API impact and know whether there are changes in API. But then that's not all. Like things get documented properly. Like I said, the documentation team does that, and there's also the change log. Every time we release something, we release a new version, there is a change log. For libraries, it's very lazy, to be honest. For libraries, we just use git log, and we will just get like the summary of the title of each commit and put it there and say like, if sounds interesting, just look at it. But for services, like real services that people are going to deploy, then we really use a proper change log that is documented basically by developers, which doesn't mean it is good. Actually, probably means it's bad, but anyway.
Okay, but hypothetically, if people wouldn't be reading documentation, would they ever?
Thank you.
Yes. But as I said, hypothetically, if people are not, they will probably find out when it's too late, right?
It's all about communicating properly. Like in our case, Openstack is an open source project. Like there's not really a one company behind it. There are like many gazillions of companies behind it. And that means that we're all responsible of documenting our own changes. So if I'm breaking something or I'm implementing something new, I will try to, well, not everyone does that, but some people has other strategies basically. But I will try to just like at least write blog posts that will go through our Planet aggregator and so that people just can read it. And then obviously document the change properly in the wiki page so they can go to the changelog. But you do expect people to read it. Like there's no other way to communicate it. If I'm talking to you and you're just like, la la la, I don't want to hear you, then you just probably are going to take some changes that are going to break your software, basically. So it's the same interaction. I'm telling you what I'm changing. I'm making it clear for you. And if you're not paying attention, there's nothing I can do. Like I'm not going to install it for you, basically.
Yeah, no, sure. But if you talk about like log messages, like if developers use a library and they start to get more log messages, you could say, well, they will ignore the log messages, which is not unlikely.
Yeah, that is true. That is true. For developers, like in the case of developers consuming a library, it is true that sometimes those go like ignore. But in our case, it is very useful for DevOps because when they install it, and they're always like restarting their services, they're always like looking the log and reading every single line and see if something breaks. And then they will see the warning and say like, hey, you know what? Like this function is going away. And they normally like freak out and they start like filing bugs. And I have a warning, I have a warning. But you say like, okay, yeah, that's normal, that's expected. Just make sure you upgrade your, I don't know, your configuration option. Like that value in the configuration options is going to change. The default value is going to change. So make sure you use and you set up the value that you really want and that kind of thing. So don't rely on defaults. Like defaults are, we try to make the defaults the most sane defaults, but they're not necessarily the most sane. So don't rely on those. Try to use your own and that kind of thing. So all that gets locked so that people just like DevOps, for instance, can read it when they restart the services.
Okay, thank you.
Questions? Oh, there's one.
Hi. In case when you are creating software, your users usually don't read documentation because they are not developers, they are users. And what do you think, what are the best channels to communicate with them, to inform them that something will change, that something new will happen or something old will disappear?
So that depends on what kind of software we're talking about. Like if it is a library, it's certainly the user of the library will be a developer, someone like that wants to consume your library. If we're talking about a final software like a desktop application or an API, I believe like there are different ways. I'm not an expert in desktop applications, but I can tell you from an API standpoint, like obviously, like I said before, changelogs, they're very important. Documenting the changes are very important, but the other way is providing a way for the user to introspect it. Like when an API is going to change, you can provide some feedback to the user. Either if the user is consuming your API, so not your web application, you have an API, HTTP API for example, and your user is consuming it, you have a way to provide some feedback in it. Either, I don't know, adding a custom header saying, hey, this call is deprecated, you should be using the other one. You can also add a way to introspect your API, having a home document, so that the user can just call the root URL, and they will get the whole scheme of your API. So they can read what's being supported and what's going away. We have that in OpenStack, for example. Like most of the services have in the root of the version, like you have /version1/, you'll get the whole API scheme, so you know what endpoints are supported. And if you don't put the version, you'll get the whole scheme of the versions, and you'll know what version is supported, which one is deprecated, and which one is the current, basically. Because we have current, it's the latest released version. We have supported, which basically means it is not the latest, but we're still supporting it, and if there's a bug, we're going to fix it. And there's a deprecated one, which we don't care what happens with that one. Does that answer your question?
Yes, thanks.
Awesome. Lunchtime. Oh no. Damn it. Damn it.
Oh,
Yeah, back there.
You're all the way in the back.
Hi, do you somehow track which version of your software is most popular among your users? For instance, you have, I know, version 3 and 2, which are like 3 is backward incompatible. And do you know that maybe most of the users still use version 2, and is this somehow affect your development process?
We kinda sorta do that. So we do track which version is, we do track the upgrade path. For example, if you're running Icehouse version and you want to upgrade to the Juno version, did I talk that much? We'll track which version you can go from and to. So we'll tell you. Hello. Oh, okay. We'll tell you if you can go from Icehouse to Juno, and that's our way to just give you some guarantees. Since we don't support downgrade versions, we'll not keep track of that. We do have a way, kind of not formal way to know what users are using what version, but some users just don't want to tell you because that's like private information. Like I personally don't know what version of OpenStack Rackspace is running, and I don't know what version of OpenStack HP Cloud is running, for example. But we do know what version of OpenStack the CERN is running, for instance, because that information for them is not private. And that's very valuable for us. So definitely gives us more information on where we are standing and where we want to go to and what kind of things we have to take the most care of, basically. Because like I say, if you're running Folsom, which is very old right now, and you want to upgrade to Icehouse, you will suffer a lot because we didn't take that much care of all these upgrade path and backwards compatibility and all that kind of things. It's not that it wasn't important for us, but priorities were kind of different at the time. But for now, right now, for us, that's a major part in interoperability between our APIs as well. So we're putting a lot of more effort. So does that change the way we work in OpenStack? Yes, that definitely changes the way we work in OpenStack. We take good care of respecting all the -1 version and -2 version. We have a stable maintainers team, and we make sure that few people really know how to what to allow and what not to allow in those stable branches, so that we avoid breaking the current deployed applications, basically. Thank you.
Okay. Yeah. Thank you very much.